dear students. I'm Meghamala, working assistant professor from Electronics and Communication Department. And today I'm going to talk about, or else I'm going to share something about the definitions from the unit module 3, that is behavioral modeling. So in the behavioral modeling, we will discuss some definitions and terminologies which are very much needed for us. So in the behavioral modeling, as I know that, as we have discussed already, behavioral modeling is one of the high level of abstraction modeling. SN is a keyword. So SN is a keyword, not assign, always at the block. Okay, always at the rate is a keyword where we are using, or else it is a keyword which is meant for the program to be written in terms of behavioral modeling. So coming to the behavioral modeling, so behavioral modeling in Verilog, it contains procedural assignment statements. So in the behavioral modeling, we have come across different types of statements. So each statement consists of some assignments. The statements are meant in terms of assignment statements, right? So assignment statement consists of to the left of the assignment operator, we have the variables to be mentioned, to be declared, and to the right of the assignment operator, we have we need to mention the expression. So here it contains a procedural statements. The execution of this procedural statements, they execute sequentially. Okay, they execute sequentially one after the other, and which controls the simulation and manipulate variables of each data type. So here in the behavioral modeling, we can manipulate and we can simulate all such procedural assignments. So manipulations, all the alterations can be done easily, and as well as the simulation also can be done easily. Okay, the synthesizing and simulation of the behavioral modeling can be observed easily with respect to the data types that you are considering. This is all about the behavioral modeling. Remember that behavioral modeling is a high level of abstraction modeling. And then, what is procedural constructs in behavioral modeling? So, in the behavioral modeling, as I said, we have few assignments, right? Assignment statement. The statements are concerned with respect to the assignment statement. Some are continuous assignment statements, some are implicit continuous assignment, explicit continuous assignment, some are procedural assignment, and some are blocking and non-blocking assignment. So, the procedural constructs. So, what are these procedural constructs in behavioral modeling is, now, the Verilog always procedural block in the infinite loop that repeatedly executes a statement within the loop. In order for simulation time to advance, the loop must contain some type control or event control. So here, there are some constructs in the behavioral modeling, and those constructs always, always starts with the keyword always. Always at the rate is a basic keyword in order to start, or else in order to write some assignments. Okay, so basic keyword is always at the right, and these procedural constructs, they are of different types. That is assign and deassign, fork and release. So what is assign and deassign? That means, as I said we can simulate and manipulate. We can manipulate, right? That means what? We can change. We can give the values, or else we can remove the values. So if you are considering this construct assign and deassign, we have to make sure that if you are adding some values to this data types, that means what? We need a keyword assign. And if you are omitting some values out of the data types, then you have to use the keyword deassign. And similar fashion, if force and release, okay, force and release also are similar to this assign and deassign. So forcing means if you want to give some values, or if you want to add something to the code, then this is nothing but the force. And if you want to release some statements, and that is nothing but the release. So these are the two procedural constructs that we can find out in the assignment statements. And then, what is procedural assignment? So procedural assignments are used for updating register data types and memory data types as well. So these procedural assignments are they are meant for updating the register data types and as well as the memory. So in order to updating the register and memory, so these procedural assignments are made used, right? And the expression in the blocking procedural assignments is evaluated and assigned when the statement is encountered. So basically in the blocking statements statements are represented with equal to symbol, and non-blocking statements are represented with like this. Okay, so basically in the blocking assignments, the blocking procedure assignments, we see these assignments are evaluated. Okay, these are evaluated and assigned when the statement is encountered. So when you are encountered with the blocking statement, then such blocking statements can be evaluated. Okay, so the evaluated is nothing but, as I said you, this is the assignment operative, and on to the LHS and on to RHS. And on to RHS we have the expression, and on to LHS we have the variables, right? So in order to manipulate something, okay, in order to execute this particular assignment statements, then you can evaluate, okay, you can evaluate the variables or the values, and also and assigned when the statement is encountered, right? Then this can be in the form of fixed delays. So here the delays are observed as fixed. There is no change in the particular procedural assignment statements, and they are represented with ASH token. So as we have discussed few lexical tokens, and the representations of delay is observed as ASH, and a delay until an expression evaluates are true, represented within the wait keyword. So now our thing is just to see whether the expressions are true or false. So in order to know the expression is true or false, then we have to wait, right? So in that waiting procedure, in order to wait that particular things to be evaluated, then the wait is a keyword where we have to use. So in order to wait after the evaluation, if you want to know the condition whether it is true or false, we must wait, right? So in order to wait that, we are using a keyword called wait. So all these things you will be observed in this procedural assignment statements, right? Then coming to the loop. So in the behavioral modeling, we have few looping statements, and those looping statements are about the for loop, while loop, if else loop, if else loop, and so on, right? So what is a loop? Basically, it is most widely used, a for loop is a most widely loop. So here in the looping systems, we have if loop, if else loop, and for loop. So among if else and for loop is used most widely. Okay, most widely for loop is used in the software, but it is primarily used to replicate hardware logic in Verilog. So here, why are we going, or else why are we considering a for loop as a priority? Because just to replicate the hardware logic, just to show the hardware logic. Okay, hardware logic is nothing but, for example, if you are considering the mux. So mux is the output of mux is observed purely on the selection lines and as well as the input, right? The output is observed purely on the selection lines and input. So this is nothing but the logic. So this is nothing but the hardware logic. So here, just to replicate the hardware logic, for loop is most widely used. Then the idea behind for a for loop is to iterate, to set a statements given within the loop as long as the given condition is true. So as long as the given condition is true, the for loop is kept on executing the statements. Okay, unless and until if you find the true, the for loop is kept on executing the statement. It just iterate. The loop is to be iterated continuously to set the statements within the given the loop as long as it is meant for the true. Okay, if it is meant for the true. And then for suppose if it is meant somewhere it is around false. So what happens is again the for loops come into existence with the following conditions. For I is equals to 0, I less than 1, and then I plus plus. So here you will see the expression. This is the expression. This is nothing but the condition, right? This is not the condition, and this is nothing but the incrementer, other than arithmetic incrementing. This is what you will observe in the for loop. So unless and until you observe the output is or else the condition must be true, then the for loop it keeps on executes as many as time. Then here the representations of for loop in a proper coding is represented as initialization, condition, and update as well. So here first we will initialize, and then the condition goes like this. So this is the condition I less than 1, and then what happens? This is the update, right? So here initial value of the variable is set. It is executed only once. So this initial value, it is set once and it is executed only once. That means I is equals to 0. Some value is set, right? For example, I can take I is equals to 10. That represents I less than 1 and then I plus plus, or else I less than 10 I plus plus. So first thing is in the initialization, what am I doing? The initial value of the variable. This is a variable and initial value of the variable is set. And then it is executed only once. The execution is the execution is done only once in the initialization and then goes with the condition. So this is a condition. So in the condition, our expression is evaluated. So here the expression is evaluated. In the condition, the expression is evaluated to be true, body for the loop, and are executed else the loop terminates. So once in the expression, this is nothing but the condition, the expression goes with the condition, and if it is true, meant for the true, and then finally the for loop, it will terminate. If you are observing anywhere, it's false, and what happens is the for loop again it takes its position back. It start executing until unless if you find the condition is meant for the true, it just keeps on executing. Then update is nothing but after execution for loop body, the variable value is to be updated. The value of that particular variable is to be updated. So this is a small example where he has given module, for example, initial array. Okay, here we have a 10 bits and initial begin, update the array. Now for using the for loop, okay, using for loop, how we were writing is for integer I is equals to 0. This is initialization, this is a condition, okay, and this is the update. So initializing I is equals to 0 and the state execution, the expression with respect to the condition follows as I less than size of an array. That means I less than here 10. Here the array is 10, right? So I less than 10 and then goes with I plus plus. And now I'm beginning the array. Okay, how I plus plus goes on array I, which is equals to I into I. Then I'm just ending up. And as I've started as I've started initial or else begin, I'm just ending this. Okay, the mechanism of this initializing, condition and the update. And then following this next part is all about the display. So the display array elements with respect to the for loop goes I is equals to 0, I less than and I plus plus. So the display and end module end. Okay, so this part is all about the mechanism and this part is all about the display. So the output, how will I observe is, as I'm considering this for loop of array 10. Okay, for loop of array 10 by using a multiplication I is equals to I into 1. So array 0, 0, and if it is 1, 1, and 2, 2 into 2, 4, 3 into 3, 9, 4 into 4, 16, 5 into 5, like that, 9 into 9. Okay, so this is how the execution of a particular procedural assignment statements goes on. And now coming to conditional statement. So we all know the conditional statements. So the conditional statement starts with the if. These conditional statements are make a decision. Yes, obviously the condition is nothing but it just used to make some decisions on either statements when the if block should be executed or not. So it's purely depends upon the to make a decisions. In order to make a decisions whether the if statements is meant to be executed or not, or else sometimes it may go with true and sometimes it may go with the false statement. So here we have a statement and if condition goes with the expression and as well as a statement, and then one more expression with a statement. Finally, if it is true, if not true, what happens if it is false, right? So if not true, else is false, and then with the executed of the statements, finally end module, right? So here the expression is evaluated. This expression is evaluated if it is true. This expression is evaluated if it is true. That is, if it has non-zero value. Non-zero value means 1. That means what? If my I is equals to 1, then the expression goes as true. So the first statement executes, right? And then if it is false, what is that? When it is false, when my I becomes 0. If it is non-zero, then the condition goes with the true. If it is 0, the condition goes with the false. And then if there is an else statement. So here in the particular code, we observe the else statement. So what is this else statement? Else statement is if it is not true, obviously else it is false. So the else statement executes. If it is not true, else if the condition going as per the non-zero value as true, else it may goes with the 0 values of false. Then the numeric value of it, if executes, is tested for being 0. Certain shortcuts are possible. So as if it is going with the else as false, certain shortcuts are possible. There are a few shortcuts just to in order to overcome this, the conditional statements if and else. Then Coming to the while loop. So this while loop is used in software language. In the C language, we come across a while loop. So to run some code for an indeterminate amount of time. Okay, so the while loop does some actions until the condition it is checking is no longer true. So here, what is while loop is talking about is until and unless if you are going to observe the true, okay, if you are going to observe the true, the while loop keeps on executing. So it is checking it is checking no longer true. Okay, that means what? If you observe somewhere else false, then what happens? The while loop will start execute. It will terminate. So here, if you observe statement, repeat expression statement, repeat expressions, begin, statement, and end. So here, the while loop, unless and until the statement goes true, the statement is no longer true. If it is no longer true, that means if it is false, what happens? The statements get repeated. Okay, the statements will get redundancy of the statements can be observed if there is no longer the true is followed. Okay, so that is about the while loop. Then there are a few constructs. As we have discussed in the procedural construct, we have discussed about the assign and deassign, right? And force and release. So these are the constructs. Likewise, we have one more construct in the behavioral modeling, that is a wait construct. So what is this wait construct? Wait construct, it makes a simulator wait for the specific expressions to be true before proceeding with the following statements or group of assignments. So this wait construct, it will make the simulator to be wait, okay, for a specific time period. It will make the constructor to be wait, to be true before the preceding expression. That means what here, for example, wait for the clock. Okay, this statement, the constructor using the wait constructor, what are we doing is we are just making that statements to be in an ideal position. Wait clock at 2 delay of seconds. Okay, at A is equals to B, the delay of 2 delay of seconds, we are making that statements or the statements to be that assignment, particular assignment statements to be in a hold position. Okay, to be in a hold position. Unless and until if you are observing any true condition is to be satisfied, till that position, okay, till that end, we are making to wait the constructs, right? So that is nothing but the wait construct. So the wait statement is used to hold the system for a certain time duration. So we are making that construct to hold. Okay, to hold. Here I am making it to hold for 2 nanoseconds of time delay. Sometimes the wait statements can hold up to 10 nanoseconds of time delay. So it is nothing but just to hold the statement or the system to certain time duration, and it can be used in 3 different ways. So this wait statement or this wait constructs can be used in 3 different ways. One is wait until, wait on, wait for. So what is this wait until? It is synthesizable statements. So wait until clock is equals to 1. Okay, so until the clock signal goes as 1, until the clock signal goes as 1, the wait construct, the construct has to, or the statement has to wait. Okay, so that is nothing but the wait until. And then wait on, it is also synthesizable and holds the system until the defined signal is changed. That means what? Wait on clock. So until some changes, until some transition of a clock changes from 0 to 1 or else from 1 to 0, from clock to unclock or unclock to clock, it has to wait. That means what? The wait on clock will hold the system until clock changes from 0 to 1 or from 1 to 0. So this sort of construct also we can make use of, in order to write when we are writing the code based on the wait constructs. And one more construct pertaining to this wait is wait for. So wait for is a non-synthesizable. Okay, where it is wait until and wait hold, they synthesize. Okay, that means what? They simulate, or else they just look out for the any errors or bugs. But whereas here wait for is a non-synthesizable, it holds the system for a defined time. Example, wait for 20 nanoseconds. That means it will hold the system for 20 nanoseconds. So wait for 20 nanoseconds. That means what here? If the system is going to hold for 20 nanoseconds, we cannot able to do anything. But whereas here wait until, we can able to manipulate, or else we can able to sort out of the things easily in between. in the process, when the process is going on, in between the process we can able to do it. But whereas in the wait for construct, we cannot make any changes, or else alterations cannot be done. Okay, so the system has to be in hold for 20 nanoseconds if it is mentioned for 20. If it is 10 nanoseconds. So this is about the wait construct. And coming to blocking assignment, so as I said you, blocking we are representing it with equals to, non-blocking assignment is represented with like this. So blocking assignments are all assignments within an initial or an always block done through equality. So this is a blocking assignment statement representation. So these are executed sequentially. So blocking executes, they execute sequentially. If you observe here, module, register, 8 bits of registered story, and we have A, B, C, D, and totally 5 modules that we are executing. Initially, what am I doing is, my A is about 10 bits of hexadecimal number, and I'm displaying it with ABC. And my B is about that with 10 nanoseconds of delay, and with 8 bits of hexadecimal with number I'm displaying. And C also going as per the 8 bits of hexadecimal number. And then finally, after presenting these numbers, what am I doing is, I'm ending up this. And then initial begin now, A, B, C, D, E. I have A, B, C, D, E, right? So A, B, C, I'm just representing it with the different things. C, A, F, and 30, H30, right? And now what am I doing is, for 5 and E. So for 5 and E, I'm representing the 8 bit of nanoseconds of 8 hexadecimal bits as AA and 55 and end module. So in all these things, if you observe, okay, if you observe here clearly, all the statements are happening with equals to, right? So equals to are nothing but the blocking assignments, right? So we have representing all the variables A to E. We are representing some numbers. Okay, we are representing some numbers. So those numbers representations are considered with respect to the hexadecimal. If it is with binary decimal. If it is octa number of representation. So binary representation of numbers can be observed over here. And then with some time delay. So for A, B, in from A to E, only for B, D, and E, all the representations, the binary representations are done with respect to the delay, okay, with respect to some delays. But whereas the other numbers, directly we have confined with some numbers. So these are the blocking assignments. And coming to the non-blocking assignments, so here if you observe, the non-blocking assignments are represented like this. So everything, there is a basic similarities we can find between the blocking and non-blocking, whereas only in the non-blocking assignment the representation goes like this. So this is the only difference. If the assignments are to be effected concurrently, a facility called the assignment is variable. For such conditions, the symbol signifies a non-blocking assignment. So this is a symbol where it is significant the non-blocking assignments, and the execution of all the statements. The non-blocking statements, execution of non-blocking statements are done concurrently as well, like the blocking statement. So this is nothing but the same register. It has a 8-bit of memory, where 8-bit of memory, all the 8-bit of memory are segregated, or is it given to each and every specified variables A, B, C, D, E, with the delays as well. Okay, with the delays as well. So this is about the non-blocking assignments. And here also in the blocking and non-blocking assignments, there are few constructs. With the help of few constructs, we can easily code the blocks. So here, what are the parallel blocks? All the procedure assignments within a fork join are executed concurrently, and one can use a fork join block within a begin end block, or vice versa. So here, fork join, assign, deassign, fork join, okay, assign, deassign, fork join, force and release. So these are the few procedural constructs in the behavioral modeling. So come in the parallel blocks. All the procedural assignments within the fork and jerk. Okay, fork and jerk are executed concurrently. So here fork and jerk are nothing but they are the constructs. So if your code is in terms of the fork and jerk construct, then you have to then in that case the statements the statements which are executed, all the statements are executed concurrently. That means one can use a fork join block within the begin end or vice versa. So within the begin end you can use fork, okay, fork A B like that, okay, we can use, but most of the constraints we cannot use within the begin and end. They can be used out of the begin and end. Some can be used out of module and end module as well. Okay, so these are the parallel block. Then define always construct. So what is this always construct? In the behavioral modeling, the basic keywords that is meant to use is always at the rate block, right? So the process has to be flagged off by an event or change in a net or a register. So here the process has to be flagged off by an event or change. The process can be meant to change within the register or else within the with respect to the net, with respect to the register. We all know what is a net. Net is nothing but they are the variables where they are meant for the connectors, right? They are meant to connect the devices, whereas a register is nothing but it is also a variable. We means it doesn't mean that it's a register where it stores information, but we say that this is one of the data type. Register is nothing but the data type. Then the process can have one assignment statement or multiple assignment statement. So here in the always construct, that means what? Always at the rate. Always at the rate we can say passage. Passage is nothing but if your code is in terms of considering the flip-flops or latches, then always at the rate remembering the positive edge. So likewise, this positive edge is meant only for the positive transition in the flip-flop. So the process can have one statement or the multiple statements as well. Then in contrast to the initial statement, always statement executes repeatedly. So always statement, always at the block, these are the statements meant in the behavioral modeling. So these statements, they execute repeatedly. Okay, we can see these always at the rate statements can be executed, and although execution started time c is equals to 0. So the execution of the always at the always assignments takes place, but with respect to time t is equals to 0. So there's a small syntax goes with this always timing control procedural assignment. So in this procedural assignment we can write always at the rate. Okay, timing control, that means delay, always delay at 10 nanoseconds at the rate or else 10 nanoseconds here, and gate or some gates we can write. This is how we can represent the always constructs, and we may use example where we have to provide clock signal in terms of Verilog. So here see, as I said, you always at the rate positive clock edges or with respect to the clock of 5 nanoseconds, which is equals to negation of clock. Okay, so this is how the representations of the initial statement, always constructs can be written over the statements, different types of statements, procedural assignment statements or non-procedural assignment statement. And this always statements produces a waveform with a 10 period of units, and that that only change upon a positive change. Okay, positive edge of the signal. So here we can change the delays can be, or else we can change the 10 nanoseconds of units that only change upon a positive edge. So only this positive edge, the 5 nanoseconds of delay can be altered, can be changed. So you will see in this sort of things can be observed only if you are considering the construct as to be wait. Only always, it's always construct. So this is about the few definitions pertaining to this behavioral modeling. And in this behavioral modeling, we have discussed about different types of constructs and different types of we've discussed about the statements, blocking statements, non-blocking statements, procedural assignment statements, and also in the so far in the module 3 behavioral modeling, we have discussed about different types of statements as well and the constructs as well, right? And also how to represent the statements in the coding format. And if you are representing, if you want to write a coding in terms of constructs, so there are different constructs we have in blocking. We have in the behavioral modeling. So fork and jerk is one construct. Force and release is another construct, and all assign and deassign is another construct. always at the rate is another construct, wait is a construct, right? So these are all constructs will help us, the driver also will help the designer. Okay, will help the designer in order to execute all the statements. Some statements can be executed concurrently. Some statements can be executed sequentially. Okay, and also we have, say this is a wait construct, which is very important in the exam point of view. If you have come across the wait constructs, these are the things that you have to mention it very clearly. And if you mention with an example, it's well and fine. You'll score good marks. And then coming to the looping statements. In the looping statements, we have discussed about the for loop, while loop, and the conditional loops as well. So for loop, while loop, among for loop, while loop, and conditional loop, if loop, conditional statements, if statements, we see that the for loops, like it waits more than the other looping statements, right? Why? Because unless in the for loop, we come across the initialization. We come across the execution, and also and as well we come across see in the for loop, initialization, condition, and updation. The for loop is meant for initialization, initializing the thing I is equals to 0, the condition I less than 10, and the updation I plus plus. Okay, so this is what we will see in the for loop. So in the for loop, unless and until if you are observing the output or else the condition is meant for the true. Okay, till that extent the for loop keeps on executing until if you find the true, the output as true, then in that moment the for loop it executes. Okay, it terminates. So that is about the for loop, and as well as the behavioral modeling and the procedural constructs and all these things, all the delays pertaining to this we have discussed so far. So I hope you all understood all the definitions and the terminologies which are meant in this behavioral modeling module 3. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.